students, now it's the time that we should come over to solving the paper from JEE Advanced 2016. If I'm not wrong, you people must have done paper 1 with the solutions. Now it's the time that we should begin up with paper number 2. So here on this tab I have uploaded the paper number 2 and I have written all the, there are all the questions we have uploaded for you. So the section has got 18 chemistry questions and we'll be solving this chemistry part only in today's section. So then what I'm gonna do is I'll be starting up with every single question. I'll try to explain you the answers for all these questions, and with due time we'll see whether we can solve out the complete questions or not. So without wasting any further time, let me come over to the very first question that has been asked and is given there. So first of all, my humble request to you all is you first need to read all the instructions. Like when you'll be giving the papers, then you must have read the instructions. So to begin up with the first question, this is question number 19, and question number 19 says that you have to tell the correct order. So let me write this screen as question number 19. So you can read the question here. The question says that the correct order of acidity for the following compounds is. You have been given 4 compounds. Let me make up the structures for all these 4 compounds. So the first one is COOH. Here you are having an OH group, and here again you have OH. This is compound number 1. To say the compound number 2 that is given to me, as we have just a carboxylic acid but we have one OH group here. So let's say this is compound number 2. Coming over to the third compound, you have an OH group there at the meta position, and the fourth compound is you have benzoic acid but with an OH group at the para position. So these are the 4 compounds that have been given to you, and you have been asked to identify the correct order of acidity for the following compounds. Now, my dear students, if you have to look into the details, you must have heard something about Ortho Effect. Now, Ortho Effect says that there will be an increase in the acidity and there will be a decrease in the basicity whenever you have any substituents at the ortho position to the main group. Now if I consider the ortho effect, I can say ortho effect will be there in compound number 1. Also it will be there in compound number 2 since OH group is there at ortho position. Whereas, so let me first of all write down, this will have ortho effect. Let's say this will also have ortho effect. Now what further we can say here is, here OH will be showing the -I effect, inductive effect, whereas, and it won't be showing any resonance effect here in the third case, and let me write 0R. Whereas in fourth case it will be showing -I, but -I will be very less because it is at para position, which is very far away from the main group. Whereas this OH will also show +R effect. Now you must be knowing the effect of -I, +R as well as ortho effects on all the different components because we are going to measure the acidity order. Now the first case will be forming the most stable anion once it will be losing one particular H+. Now let's see why is this so. If I am saying it is gonna, let's say it is gonna lose one H positive and it is gonna form COO minus, and here you have OH and here also you have OH. Now you can say this will be resonance stabilized. That means there will be a ring formation here and there will be a ring formation here. That means in the first case the most stable cation will be formed due to the chelation of 2 OH groups with the acetate. So there is a chelate ring which is formed, and this is one of the most important thing which is going to stabilize the first compound for acidity. Also if I come over to the second case, in second case also you can write the same thing. You will have COO minus and you have an OH group. Now here also you should say there is a chelation, but in the first case there were two chelate rings which were formed, and in the second case there is just one chelate ring which is formed. So also we know that +R group is gonna reduce the acidity. Why is this so? Because +R group in, let's say, case number 4, If I am writing an OH group, this OH group is going to donate the electrons, which is in turn going to donate the electrons to CO minus. So the negative charge density is increasing, and hence we cannot say this is the correct answer. So just to write the correct answer, I will go for option number 1, where it says first is greater than second, which is greater than third, and which will be greater than fourth. Now let us refer to the question. So this question here says first, second, third, fourth. Option number A will be the correct option for question number 19th. Now since we are done with first question, it's a time that we should move over to the second question of this paper. The second question of the paper states that, yes, the question is, so let me put up the another screen. So coming over to the second question, this question states that the geometries of ammonia complexes of nickel 2 plus, platinum 2 plus and Zn 2 plus respectively are. So you have to consider, now see, let's first look into the options. So the three options that are given are octahedral, square planar and tetrahedral. And one very important thing to be known to you people, that you have to find out, or you have to tell what should be the geometries of nickel 2 plus, platinum 2 plus and zinc 2 plus. So you have to tell whether the geometry is octahedral or it is square planar, or let's say the geometry is tetrahedral. Now how we are gonna do this question? Let us see the complexes of ammonia. So he has said that you have to form the ammonia complexes. Now ammonia complexes, if I'll be forming, it will be nickel NH36, then you will have a 2 positive because nickel is there in +2 oxidation state. Platinum should be forming like platinum, again NH34, and it will be 2 plus. Similarly zinc can also form a complex with 4 coordination number ZnNH4 NH3 whole 4 2 plus, yes. So that means all are having +2 oxidation state. Now this is very clear that nickel can have 6 ammonias coming. So it will be forming a geometry like completely octahedral, because nickel will be very stable. So you can refer to the CFSE of the complete compounds so formed. You will find that when nickel is forming a complex with ammonia with +2 oxidation state, the CFSE in this case will be much larger as compared to the CFSE which will be obtained if nickel would have combined with only 4 ammonia molecules. Hence we can say for nickel you will always have octahedral complex with ammonia. Now if I ask you to look into the options, it is very much clear that platinum, since it is like, you should be knowing this fact, if you are going to go from 3D to 4D to 5D series, the tendency for the metals to form square planar complexes increases very much because of JT distortion. Also for zinc, I can say now zinc will be having, zinc is D10S2, so it is Zn plus 2, so this is gone and you have D10. That means in order for zinc to form complex with 4 ammonias, it should be tetrahedral in nature. So I think we got the options for this question. Like for nickel, I should have octahedral. For platinum, I should have square planar. For platinum, it's square planar, and for zinc, it should be tetrahedral. Let me look into the options which were given on the sheet. Octahedral is fine, so B and C are wrong. Then square planar and tetrahedral. Again, I'll say option number A is the correct option for this particular question. Now students, having done with this question, it's the time that we should move over to question number 21. Now question number 21 states that the question is, for the following electrochemical cell at 298 Kelvin, so there is an electrochemical cell which is given to you. Let me write it here. You have platinum solid and then you have hydrogen in the gaseous state, 1 bar pressure. Then you have H plus aqueous state, 1 molar. Then you have a salt bridge. Again you have M plus 4 aqueous, M plus 2 aqueous. So it's oxidation reduction half cell. In the right hand side you can see very clearly. Now for this following electrochemical cell, the temperature is given to be at 298 Kelvin. The E naught of the cell, the E cell has been given to you as 0.092 volts. When, so he's saying that the E cell has been given to be this value when the concentration of M2 plus aqueous divided by M plus 4 aqueous is 10 raised to the power x. Okay, now you have been given one more thing, and this thing which is given to you is E naught of M plus 4 to, let's say M plus 2 is given to us as 0.151 volts. 2.303 RT by F value has also been given to you as 0.059, and you have been asked to calculate the value of this X. So this question is very simple. Now how are you going to do this question is also, the question is simple, as well as let's say the solution is also simple for this question. So first of all, it's a very general convention that you have to write the two reactions. So first of all, let me write at anode what is happening is hydrogen in the gaseous state is going to form into 2H positive in the aqueous state plus let's say 2 electrons. And let me write the reaction at cathode. So I should write the reduction reaction. M plus 4 aqueous will combine with 2 electrons in order to give me M2 plus aqueous. Now you have to first of all write the balanced chemical equation. My dear students, please keep in mind that these 2 electrons should be equal. Then only you will be able to get the balanced chemical equation. So you will say hydrogen gas plus M plus 4 aqueous is going to give us 2H plus aqueous plus M2 plus aqueous. Now you can very nicely use the Nernst equation, and according to the Nernst equation you know that E cell can be written as, so E cell is equal to E naught cell minus 0.059 over N log of concentration of products H plus raised to the power 2 M2 plus aqueous divided by M plus 4 aqueous and with the pressure of hydrogen gas. Now E naught cell, how can you write? E naught cell is reduction potential of electrode where reduction is taking place, that means M plus 4 to M plus 2 minus the reduction potential of electrode where oxidation is taking place, H plus to H2. Now if I ask you to put up the values, since almost all the values have been given to you in the question, so simply what you can do is to put on the values in this above equation. So putting on the values, I will get 0.092 is equal to 0.151 minus 0. So you know that the standard reduction potential for the hydrogen electrode will be 0. Again minus 0.059 divided by 2 log of, so this has been given as 1 square. Let us write M2 plus divided by M plus 4, and then here also you have 1. So if you solve this value, since I solved it like a minute before, so what I got the answer as M2 plus divided by M plus 4. This was coming out to be 10 raised to the power 2, and in question he has given us this is coming out to be 10 raised to the power x. So you can very nicely say that the value of x is 2. Let us see. So value of x is minus 2, minus 1, 1 and 2. So D will be the correct option for this particular question. It's good that we are done with third question also. Now is the time that we should continue with question number 4th. And question number 4th will be 22nd question in this series. So if I switch the tab so that you people can look into the question says that the major product of the following reaction sequence is. So there is some reaction sequence which is given to you and you have been asked to give the major product of this particular reaction. Let me write the reactants. You have a benzene, you have C double bond O, then you have something like this. Now let me tell you what is the series of reactions that has been followed to do this. So first of all you have HCHO, that too in excess, in the presence of NaOH, and you are heating it. The second thing that you have is HCHO in the presence of H plus and then you have a catalytic amount. And you have been given 4 options. So how I'll continue with this question is I'll try to write down the steps how you are going to follow. So very first and clear thing is you have C double bond O, C, you have CH3, you have CH3, and you have one hydrogen here. So if you are going to add HCOH in the presence of NaOH, this is very good example of cross aldol condensation because you are heating it also. So this is cross aldol condensation. Now in cross aldol condensation, how you do it? First of all, OH minus will go take away this proton. It will be forming a negative here. Then this you can say is delta plus, this you can say is delta minus. So there will be an attack from the negative species to the positive species so that this O will get a negative charge, and hence you can write it as C double bond O. You have C, I have got a CH3, I have got a CH3, then I have got CH2, and then there will be one O minus. So this O minus will be substituted since we are adding H plus also. So first of all, you will get the compound C double bond O, CH3, CH3, and then you have a CH2, and then you have OH. Now again he is saying that you have added HCHO in excess. Let us see whether there can be furthermore reaction which can be taking place in this particular condition or not. Now you can very nicely see that if I am adding HCOH in the presence of NaOH, now in this particular reaction I have got no alpha hydrogen. So if there is no alpha hydrogen, you can say that this is an example of Cannizaro's reaction. But this reaction will not be simply known as Cannizaro's reaction, it will be simply known as cross Cannizaro's reaction, because you have got two different components which are going to show this particular reaction. So we can say that one of the C double bond O will get converted into OH, and the another C double bond O will get converted into COOH, so acidic group. So we can say the product will be, you have CHOH, and then 2 here, and then you have CH2OH, and then you have HCOO minus. So let me write it again. Yes. So now let us see what else he has added. To this particular substance, he has added HCOH, but not in the presence of NaOH. This time he has taken H plus. So, and that too in the catalytic amount. That means we can say that since we have got two alcohols, OH groups are there, and this is a C double bond O group. So we can very nicely say that this is a reaction of acetal formation. And the acetal so formed in this case will be something CH, you have O, and then you have a CH2. So this C double bond O and this H and this H. So there will be a release of water molecule. So you will have O here. Then again you have CH here, and then you have two methyl groups. So this will be the answer for this particular question. Let me see what are the options that are given. So option number A, as per you can see, matches the answer very nicely. So we can say option number A will be the correct option for question number 22. Now having done with question number 22, it's a time that I should be teaching you how to do question number 23. Okay, so coming over to question number 23, the question says that in the following I forgot to show you the question. So the question says that in the following reaction sequence, in aqueous solution, the species X, Y, and Z respectively are. So that's again a simple question where you have to just identify what are the species. Now dear students, one very good technique to solve these questions is you should know what exactly are X, Y, and Z. But at least you should know how to get the answer from the options. We never ask you to mug up every little single reaction which is given in your NCERT or let's say any other textbook. But what we ask you is to know what kind of reactions will be shown by one particular compound. So let me prove my point by starting off with this question. The question was S2O3 2 minus. First of all, you have added Ag plus, it is going to form X. Now this X is a clear solution. Now to this clear solution you are adding another Ag positive and it is going to form Y, which will give us some white precipitates. To this white if you keep for some time, so this white with time it forms Z and this is black precipitate. Now let me first of all look into the options. Let us see the very first option. Now since Ag plus with S2O3 2 minus is going to form a clear solution, so I can say that the reactions, let me write down the reactions for you. So first of all I can say S2O3 2 minus has a tendency to combine with one Ag positive and it is going to form AgS2O3 twice whole with a 3 negative charge, so that silver here again will be having a positive charge. Now here this, let me say this is compound number X and this is very well known that this will be a clear solution. However, if I further start adding Ag plus, then it has to get precipitated as white in color. So it must be a very well known compound Ag2S2O3. So this is Y and it settles down as precipitate which are white in color. And these white precipitate, this is very clear thing that these Z which are nothing but black precipitate are nothing but of silver sulfide, which is Ag2S, and this is Z. So let me see what are the options. S2O3 2 minus, AgS2O3 2 minus, 3 minus, that is correct. AgSO3 is not going to give, this will not be stable in the aqueous solution. So this 5 minus is again wrong and this 3 minus is again wrong. So again you can see Ag2S. Now the answer should have been very clear. I know the Z which are black precipitate. These black precipitates for silver are for Ag2S. So either this option could have been correct or this. But we know that if we are talking about the white precipitate, then those white precipitates cannot be Ag2SO3. The white precipitates are basically of Ag2S2O3. So I can mark option number A as the correct option for question number 23. Now, having done with question number 23, let us move over to another question, which is question number 24 in this series. And to read out the question, let me tell you. The qualitative sketches 1, 2 and 3 given below show the variation of surface tension with molar concentration of 3 different aqueous solutions of KCl, CH3OH, CH3, CH211OSO3 minus Na plus at room temperature. So the correct statements for the correct assignment of the sketches is, so he is basically asking us to tell what are the correct assignments for these sketches. So let me see. The first sketch is something of surface tension with the concentration. Second, and the first one is for KCl. Then you have surface tension with the concentration of CH3OH, and you have surface tension with concentration of CH3, CH211O, SO3 minus Na plus. Okay, so this is what is unknown. So either this is of KCl or this is of CH3OH or this is of the third option. And same thing goes for this and same thing goes for this graph. Now my dear students, I'll speak out certain lines and I want you people to see whether you can understand whatever I'm speaking or not, else I'll try it out in a very different way. Now we know this thing that water has very large surface tension due to very strong interaction. So let me explain it here. We know that water is having a high value of surface tension because of very strong interactions. Like now what happens generally if you start adding organic derivatives to water, like we do know na, that if we suppose start adding soap to water, or if I start adding detergent to water, it is very clear that the dust from the clothes will be removed very nicely if you wash the clothes with let's say soapy water, or let's say with the water which is using detergent rather than normal water. This is basically because once you start adding organic substance to water, suppose I have added this detergent and this is nothing but an organic substance, and if I start adding organic substance to water, then we can say that there will be a very great loss in the surface tension of water. This is because of hydrophobic interactions, because water will be, let's say, a polar compound, whereas if you start adding organic substance to this, there will be hydrophobic interactions. Now because of these hydrophobic interactions, there will be a very large decrease in surface area. Now let me compare the graphs 1, 2 and 3. In case number 3, you can say that hydrophobic interactions must have been the strongest, let's say as compared to case number 1. You can see the graph that in case number 3, the loss in the interactions is too much. That means the hydrophobic interactions in case number 3, which will be much greater as compared to the interaction in case number 1, thus causing surface tension to decrease more rapidly. That means I can say the third graph will be of this detergent kind of stuff. So let me say option number B and C are gone. Now to compare option number A and option number D, we can say that due to KCl, which is an inorganic electrolyte. So it is very much known to us that KCl is K plus Cl minus, that is an inorganic electrolyte. So now if you are adding an inorganic electrolyte to water, you can again say that the intermolecular forces of attraction will increase and hence the surface tension will increase. So KCl will be something like this, and let's say the other one left out will be CH3OH, which is again organic, and hence it will be showing a decrease in the surface tension. So I'll say not A but D will be the correct option for this particular question. Now students, I suppose we are done with the first section and it's the time that we should begin up with the second section. So students, now we were there at question number 25 if I'm not wrong. To start up with question number 25, let me first of all assign a board to that question. Literally sorry for this thing. Question number 25. Now this question number 25 states that for the invert sugar, the correct statements is or are, so that's a multiple correct answer question. So you have been given that the specific rotation of plus sucrose, plus maltose, L minus glucose and L plus fructose in the aqueous solution are plus 66, plus 140, minus 52, plus 92 respectively. Now you have to tell the correct statements as compared to whatever is given to you. So let me continue with this thing. Let me first read out the options for you. The option says that let's say the option number A says that invert sugar is prepared by acid catalyzed hydrolysis of maltose. Invert sugar is an equimolar mixture of D plus glucose and D minus glucose. Statement number C is specific rotation of invert sugar is minus 20, and on option number D you can say on reaction with bromine water, invert sugar forms saccharic acid as one of the products. Now students, you have to be very careful while you will be doing the questions of this particular type. And to continue with this question, I will first of all tell you some details that we do have for this question, and then we can choose up the correct statement. Now this is very clear thing that invert sugar is an equimolar mixture of, so I am talking about invert sugar. And this invert sugar is an equimolar mixture of two components. The first component is D-glucose and the second component is D-fructose. which is obtained by the hydrolysis of sucrose. And let's say option number A was invert sugar is prepared by acid catalyzed hydrolysis of maltose. That is a wrong option. Second is invert sugar is an equimolar mixture of D glucose and D minus fructose. So we have got option number B as one of the correct options. Why option number A is not correct? Because this invert sugar is obtained by the hydrolysis of sucrose, not maltose. So out of A, B, C, D, we have already played with the A and B option. Now let us come over to option number C and D. So option number C says that specific rotation of invert sugar is minus 20. And let me help you out solve this thing. How can I find out the specific rotation of the mixture? So we know that if I am telling you that invert sugar is an equimolar mixture of D glucose and D fructose. So the options, the theory values that you have been given are the specific rotation of plus sucrose, plus maltose, L minus glucose and L plus fructose. So you can say specific rotation of mixture is half of sum of specific rotations of both the components. So L minus glucose is given to me as I think the value is minus 52, and for another L plus fructose the value is given to me as something around 92. But what do I need actually is we need glucose, which is D. So we can say the answer will be 52 in a positive sign, and we need D fructose. So the answer will be minus 92. So we have got the individual components, and then we can say that specific rotation of the mixture will be equal to half of the sum of specific rotation of both the components. So it is 52 since it is equimolar. So you can say 52 plus minus of 92. Now whole to be divided by 2 because it is equimolar, and it will, if you solve, it will come out to be minus 20 degree. And this was option number C, I suppose. So B and C are the correct options by this time, whatever we have got. Let me play up with the option number D now. It says that now we can say you have, let me draw the structure, CHO, you have OH, H will have OH, OH, and then we'll have CH2OH. Give me a sec to write down this. Then here you will have H, H, you will have an OH here, and you have H here. So once you will be adding it with bromine in the presence of water, it will be giving me COOH. It gets oxidized and it is forming OH. Again you have H, OH, OH and CH2OH. That means if I am starting with D-glucose and I am treating it with bromine water, I will be getting D-gluconic acid. And this is not saccharic acid. Whereas if I start with D-fructose, since there were two components, so if I start with D-fructose, now D-fructose you can very easily say that it will not be reacting with bromine water, and hence option number D is not the correct option, because option number D says that on reaction with bromine water, invert sugar forms saccharic acid as one of the product, and you have seen that it is not forming saccharic acid as any of the product. So for this question I will ask you to mark option number let's see again, option number B and let's say option number C were the correct options for this particular question. Now students, done with question number 25, it's the time that I should begin up with question number 26. Question number 26, if I ask you to read, the question says that among the following reactions that have been given to you, which give or gives tertiary butyl benzene as a major product? So what we'll do, I'll try to write down each and every reaction and then we'll see what will be the products in each case, and what we have to see is we need to find out those specific set of reactions in which tertiary butyl benzene will be formed as the major product. So assuming that you people would have started up the question, and let me write down this as question number 26. So the first is you have a benzene. To this you are reacting this Br in the presence of NaOC2H5. Let's see what is going to be the reaction. So first of all, this Br in the presence of NaOC2H5, so this is tertiary alkyl bromide. This in the presence of NaOC2H5, it will undergo E2 mechanism. And if it undergoes E2 mechanism, you can say it will abstract one of the hydrogens. It will come here and it will go away. That means you will be forming a stuff like this. Now if I ask you to do its reaction with benzene, you should say that it is not gonna show any reaction in this particular case. That means A will not be the answer among all the three options that have been given to us. Coming over to option number B, let me write down the mechanism again. Option number B says that you have got something like this and then you are adding AlCl3. So once you add AlCl3, you can form AlCl4 minus and there will be a positive. A carbocation will be formed like this and you will be forming AlCl4 minus. Now you know that this carbocation will undergo rearrangement and hence the carbocation will become a tertiary carbocation. Now once this tertiary carbocation will be asked to react with the benzene ring, it will genuinely be forming this compound as this. So this compound is nothing but tertiary butyl benzene. So we have got one particular option as option number B for this question. But since it is a multiple correct question, so you should not quit with with option number B. Just continue doing the question. So coming over to option number C, you have taken something like this and then you are adding H2SO4. See, the only difference in first option and the third option is the presence of acidic medium. If I ask you to add the acidic substance, you can say hydrogen will come here and there will be a positive charge here. Again, this positive charge carbocation will react with benzene and the same reaction will go on and you can get tertiary butyl benzene as the product. So option number C is also the correct option. And now it's the time that we should come over to the last option. The last option is something like this. Let me draw it. And you are going to do its reaction with BF3OET twice. So this has been taken as solvent and I mean that's a couple, so you have taken it as BF3OET2. Now how to do this reaction, since we know that in BF3 boron is deficient of electron, whereas in OH oxygen is having excess of electrons. So there will be an attack by the negative terminal to the positive terminal, and if the attack occurs like this, and you should know this thing that this should be delta plus and OET twice should be delta minus. So the graph that you will be getting will be the product that you will be getting will be something like this. You have OH with a positive sign and BF3 with a minus sign, and OET will go away as another solvent. Now what happens in this case? This OH will leave the molecule, and as soon as this OH leaves the molecule, you will again get the formation of a carbocation which will be primary carbocation. Let me write it in detail. And plus the side products that you will be having is OH, BF3 with a minus. Now this primary cation will get converted into a tertiary carbocation. Once a tertiary carbocation is formed, you will do its reaction with benzene, and again to my convenience I can write it as option number D is also the correct option for this particular question. So students, we can mark option number B, C and D as the correct options for this question number 26. Now having done with question number 26, it's the time that I should continue with another question, question number 27. Let me first of all switch the boards. Yes, and let's read out the question. The question says that extraction of copper from copper pyrites. Now copper pyrites are CuFeS2. This involves. So there are a sequence of steps that have been given to you. Let me read out the steps. He's saying crushing followed by concentration of the ore by froth flotation. Then he is saying removal of iron as slag. Then he is saying there is self reduction step to produce blister copper following evolution of SO2. And finally, he is asking us the refining of blister copper by carbon reduction. So you have to tell which of these 4 steps are actually involved in the extraction of copper from copper pyrites. Now students, for this particular question, what I think is the better option is I should first tell you the entire sequence of the steps that are actually followed in order to extract copper from copper pyrites. So let me write down the sequence and then we can find out which will be the correct options. So this is question number 27, I suppose. So what is given to us is you have to start with copper pyrites, which are CuFeS2. Now first what happens, you have to crush them into fine powder. Now once you crush it into fine powder, what will you be getting is concentrated. Then you have to do, like, once they have been crushed nicely into fine powder, then you have to concentrate it by froth flotation. Now once you have done the concentration by froth flotation process, then what you do is roasting. And roasting takes place in a reverberatory furnace. Now if I am saying that this is a roasting process, then let me just for your convenience write down the reactions for roasting. You can say CuFeS2 will combine with oxygen in the air, and if on heating, this is going to form Cu2S, FeS and SO2. If I ask you to balance, so you can say this will be balanced. Then this FeS will further combine with oxygen and it will be forming FeO plus SO2. Once this process has been done, then it is made to undergo smelting. Now smelting means what? Smelting basically involves that iron will be removed as slag. So we are gonna remove iron as slag of FeSiO3. So what should be the reaction? You have FeO, it should be treated with SiO2, which is flux in this case, and you're gonna heat it, so it is gonna form FeSiO3 liquid, and this will be slag. Now once it has undergone smelting procedure, we can say you will be getting a copper metal, which is nothing but Cu2S plus FeS. Now this is asked to undergo self-reduction. So if it will undergo self-reduction, then this self-reduction, you should know, it occurs in Bessemer's converter. And for your convenience, again I'll be telling you what are the reactions taking place. The reactions that will be taking place will be Cu2S will be reacting with oxygen. It will be forming Cu2S and SO2. This SO2 will go away, and finally this Cu2S will combine with 2 times Cu2O, and it will be forming 6 times copper and SO2. Again it will go away. And finally, after self reduction, what you will obtain will be blister copper, and this blister copper, the refining of blister copper is done by boiling followed by electro-refining, but not by carbon reduction method. So actually, what happens is, once we are asked to refine this blister copper, this you have to do by polling, and then this has to be followed by electro-refining. But what is said in the question is, he is saying that you have to do the reduction by copper method. So that is not the correct option, first of all. Now with all the description I have given you regarding the extraction of copper, and if I ask you to read the options again, So keeping in mind whatever is the complete technique, and to read the options again, the first is crushing should be there followed by concentration of the ore by Froth flotation. This is what I told you also, so this is the correct option. And then it is saying there will be removal of iron as slag. Again you can say this is the correct option. Third says that self-reduction step to produce blister copper followed by evolution of SO2. This is again right, whatever we have done. Only the fourth option which is there, refining of blister copper by carbon reduction, that's a wrong statement in this particular question. So we can mark only 3, A, B, C as the correct statements for this particular question. Now having done with question number 27, let's start up with question number 28 this time. So question number 28, let me first make you read this question. This says that the correct statements for cubic close pack CCP 3-dimensional structure is or are. So the options are: the number of nearest neighbor of an atom present in the topmost layer is 12. The efficiency of atom packing is 74%. The number of octahedral and tetrahedral voids per atom are 1 and 2 respectively, and the unit cell edge length is 2√2 times the radius of an atom. Fine enough. So having read all the options that have been given to us, now I'll tell you certain points and then we'll try to coordinate which all points are correct and which all points are not correct. So to mark it as question number 28, now he's referring that for cubic close packing. So CCP, if I'm not wrong, it is ABC, ABC, ABC kind of packing. Now the first option was saying that in the topmost layer, the number of nearest neighbors of an atom present in the topmost layer is 12, which is wrong. As per you can see, so it's something like this. You have 1, 2, 3, 4, 5, 6, and then let's say this is a central atom. So this is, let's say, layer number A. So layer number B is something like this, and let's say then you have layer number C, which is something like this. So on the top of A will also be layer number C, and it will be something like this. So now if I say in the topmost layer, each atom is in contact with 6 atoms in the same layer and 3 atoms below this layer. So now he is very clearly talking about ABC, ABC pattern, but specifically he has written the word topmost layer. So topmost layer means what? You just have to consider 1, 2, 3, 4, 5, 6 layer number A, and then you have to consider another layer number B. So that means 6 atoms from this layer and 3 atoms from this layer. So there will be just 9 nearest atoms, because he's specifically talking about the topmost layer and not about the coordination number. So many students would have done coordination number is 12. So yes, the number of nearest neighbor is also 12. But my dear students, he's talking about topmost layer only. So be very careful. So A is not the correct option. Coming over to B, I can say that the packing fraction, yes, for CCP, this is well known fact that the packing fraction is 0.74 or 74%. So how do you calculate packing fraction? This is 4 into 4 by 3 pi r cube, since Z value is 4, divided by 4r over √2 whole cube. So if you solve this, you'll get it out as 0.74 or 74%. So B is the correct option. Then we have the number of octahedral and tetrahedral voids present per atom are 1 and 2 respectively. Now we can very easily say that each FCC unit has effective number of atoms as 4. So octahedral voids are 4 and tetrahedral voids are 8. So per atom it is 1 and 2 respectively. Again, option number C is correct. And if I come over to option number D, this is again good, because for let's say CCP is nothing but you can correlate it to FCC, and for FCC you know that this is face centered cubic unit cell. So the atom at the center will be touching all the 4 corners, but all the 4 corners will not be touching each other. So I can say under √2a is equal to 4r, and this is what will go for FCC as well as CCP. So for this option, for this question, I can say option number B, C, D, A. A was wrong, B, C, D are the correct options for this particular question. So students, now I think it's a time that we should continue with question number 29. Let me first of all make you read the question. Give me one sec so that I can show you the question. Yes, so question number 29, coming to this question. The question says that the reagents which can be used to bring about the following transformations is or are. So you have one transformation where the COH part is same, epoxide part is same, whereas the aldehydic part has been converted to alcohol, and C double bond O, every part is same. Now you have to select which will be the best reagent, whether it is LiAlH4 in C2H5 twice O, which you can be using for this particular conversion, or you have borane in THF, or you can be using NaBH4 in C2H5OH, or you can be using Rene-nickel in the presence of hydrogen in THF. So let me first of all write down this question, and I'll tell you some facts which are very, very important for this particular question. So yes, let me write down. This is question number 29. And this question number 29th, it says that, let me first of all tell you what are the problems with all these reagents and how am I going to choose all these reagents specifically for this particular reaction. The first is you have LiAlH4 in C2H5 twice O. Then you have BH3 in THF, and if I take Rene-nickel in the presence of hydrogen. Now one important fact regarding all these three reagents that we have been using is that either they can reduce all the functional groups or can reduce some of the functional groups of the compound given in the reactant site. So the very basic thing is we should not be using that particular reagent which will be reducing all the functional groups, because it is very specific. I told you that there is only one particular group, COH, which I want to be reduced to CH2OH. Now, so if I keep all these things aside, but if I take into account NaBH4, this is a very, very good example of selective reducing agent. So this is selective reducing agent. Now this cannot reduce ester, C double bond O, so this ester bond will be as such, so ester group will not be dissociated by this. Moreover, the carboxylic acid group COOH, this even won't be affected. So again we are on the safer side with this, we are on the safer side with this also. Moreover, if I keep on talking about the epoxide bond, this epoxide bond will also not be cleaved, and hence we are on the safer side at this position also. But if I take into account the aldehydic group, the COH group, this will be reduced into primary alcohol, which is CH2OH. And hence we can say that you should have only and only option number C, which will be the correct option for this particular question, since we are done with this thing. Now, having done with question number 29th also, it's a time that we should continue with question number 30th. Okay, so to move over to question number 30th. Again, first of all, it's a time that I should show you this question. Now, question number 30th, if you people have to read. The question says, mixtures showing positive deviation from the Raoult's law at 35 degrees C is or are. That means you have to talk about all those mixtures in which you have to show the positive deviation from Raoult's law. So let me tell you one again very, very important thing. So first of all, I think you people would have read the examples. The examples are carbon tetrachloride in the presence of methanol, carbon disulfide acetone, then you have benzene and toluene, and finally you have phenol and aniline. Now, how can we say or how can we justify the answers? Listen to me very carefully. Since I'm talking about positive deviation, Now this positive deviation basically says that suppose if you have taken the solvents, let's say AA, and let's say there was another solvent BB. Now what the fact is, if I am not mixing the two, then whatever will be the force of attraction between AA molecules and whatever will be the force of attraction, let's say, between BB molecules, and if I am mixing the two, so we will have both AA as well as BB in picture. Now whatever will be the force of attraction between these molecules, if the total force of attraction between reactants is found to be very equal to the total force of attraction between the product side, you can say that there will be no deviation, or else you can say this is the ideal condition that you have got. If however I say that the force of attraction in these molecules is lesser, so what I'm saying is if the force is lesser and let's say this force of interaction is more, so you can say that for AA or for BB molecules to get vaporized will be very difficult, and hence the vapor pressure will be reduced. But it will be showing a negative deviation. We are not concerned about negative deviation. Rather, we are concerned about the positive deviation. Now, the positive deviation from Raoult's law is possible when the force of attraction between A and B molecules will be less as compared to that between A and A plus that between B and B. Then only you can say the vapor pressure will be more in this case, and hence they will show the positive deviation from Raoult's law. Now students, based upon all these facts that I have told you, this interaction, whatever I was talking about, this interaction can be taken either in the terms of, let's say, hydrogen bonding. So you have to justify whether hydrogen bonding was more in the initial case or hydrogen bonding is more in the final case. So on the basis of this, let me tell you, now I'll be speaking out, like we'll take into account all the options. So let me first take option number A. Option number A says that you have CCl4 and then you have methanol, CH3OH. So we can say that earlier when methanol was present alone, there must have been hydrogen bonding. But when CCl4 is added to methanol, the hydrogen bonding will be lost and hence force of attraction will be less, but it will be showing a positive deviation. So we can say hydrogen bonding of methanol will break when CCl4 is added, so the bonds become weaker, resulting in positive deviation. So A is the correct option. Coming over to option number B, this is carbon disulfide and acetone. So we can say mixing of a polar and a non-polar liquids will produce a solution again of weaker interactions leading to positive deviation. Again you can say here I am mixing one polar substance and another non-polar substance. So this is also a positive deviation. The third says that benzene and toluene. Benzene and toluene you must have studied in very previous classes, as this is an example of ideal solution, so this will not be the answer. And option number D, if I say phenol and aniline. When phenol is added to aniline, so you have OH and then you have NH2. Now there will be a strong hydrogen bonding that will be resulted in the final formation, and hence you can say that this fourth D option is also not the correct because it will be showing us a negative deviation. So students, this was all about question number 30th. Now it's a time that we should move over to another question. This another question that I'll be talking about is question number 31. So to write question number 31, let me ask you to read this question first of all. The question says that the nitrogen compound produced in the reaction of HNO3 with P4O10. That means you have to find out what should be the reaction between HNO3 and P4O10. Now you have to determine the options. Can also be produced by the reaction of P4 and HNO3, or is diamagnetic, or contains one NN bond, or it reacts with sodium metal producing a brown gas. Now let us start to work out with all the single options that have been given so as to come at the correct option. Let me start writing. So very first equation that we should know is P4O10 should be reacting with HNO3. This is what has been given. So this will form HPO3 and it will be forming N2O5. That means the nitrogen compound I'll be talking about is N2O5. If I ask you to balance this, this will be 4 times HNO3, and if you will be doing the dehydration, so what is happening is dehydration of HNO3. Now in this case you will be getting 4 molecules of HPO3 and there will be 2 molecules of N2O5 which will be produced. Now this is the required product. Now let us try to figure out which options are correct. Option number A says that whenever you react P4 with HNO3, let's say 20 moles of HNO3 will be required to react with P4, this will be forming H3PO4, it will be forming NO2 plus it will be forming water. But the product we never got N2O5. That means I can say option number A is not the correct option at least. Now if we go for option number B in this case, option number B says that N2O5 is diamagnetic in nature, and that's a well-known fact. The structure of N2O5 will be something like this. Okay, let me draw the structure. So you have N double bond O and then you have O. It should be forming a bond with O, so it should be like N, and then you should have double bond O and then you have O. That means there will be no free electron, or let's say no unpaired electron will be present, and hence you can say it will be diamagnetic in nature. So option number B is correct. If I ask you to look for option number C says that it contains one NN bond. So again option number C is not correct because there is no NN bond. So C is not correct. And again if I ask you to come over to the last option, which is option number D, it says that sodium will react producing a brown gas. So sodium is going to react with N2O5. Again, this is a good thing because sodium will be forming NaNO3 and it will be forming NO2. Now NO2 by nature is brown in color, and hence we can say that option number D is also correct. So for this multiple let's say correct answer questions, option number B and option number D are the correct options for this particular question. Now students, having done with question number 31, it's a time that I should be moving over to question number 32. Now what's there in this question number 32? First of all, let's read it out. One sec again, and let us read this. So question number 32 says that according to the molecular orbital theory, C2 is expected to be diamagnetic, O2 is expected to have a longer bond length as compared to O2, N2 and N2 have the same bond order, and He2 has the same energy as two isolated helium atoms. So again my dear students, this all is about how are we gonna decide the answers on the basis of molecular orbital theory. So again I am left with no other option but to start up with the first option. So the first option says that C2 is expected to be diamagnetic. Let us check this out. The molecular orbital energy configuration, I would first of all write down the molecular orbital energy configuration for C2 So this will be sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, pi 2px is equal to pi 2py. So we have to fill 2 and 2 here, and only we are left with 2 electrons. So this is sigma 2pz, again 2. So this is the molecular orbital configuration, and we can say that in the molecular orbital of C2 as you can see that there is no unpaired electron, and hence C2 will be diamagnetic in nature. So we have arrived at least one of the correct options, option number A. Now it's the time that we should move over to option number B. Option number B says that O2 is expected to have a longer bond length than O2. So it says that the bond length of O2 is longer as compared to O2. Now again the bond order of O2 you will find out. Let's try comparing it on the terms of bond order. You'll find it out as bond order 3, and for this you know that bond order is 2. So this is wrong, right? Because you can say that now if the bond order is more, you can say it will be smaller in length. So I'm talking about the bond will be smaller. So option number B is not the correct option. Coming over to option number C again. Now option number C says that the question is N2 plus and N2 minus have the same bond order. So let me write down the electronic configuration of N2 plus and N2 minus. So this is sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2. Pi 2px will be equal to pi 2py, which will be 2 2, and then you have sigma 2pz1. Now if I ask you to calculate the bond order becomes half number of electrons in bonding molecular orbital, number of electrons in anti-bonding molecular orbital, subtract. So half, you can count it 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 minus 4, which is 5 by 2, nothing but 2.5. And if I ask you to write down the molecular orbital energy configuration for N2 minus, then my dear students, again for N2 minus you will be writing it as, since now N2 minus will have how many number of electrons? It will have 7 plus 1. So it's 14 plus 1, 15 electrons. So the energy diagram that will be followed is sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, pi 2px2, which will be equal to pi 2py2. So again we can say sigma 2pz2, then you have pi star 2px, which will be equal to pi star 2py, and this will be 1 in this case. So any one of the two will get filled up. And if I ask you to calculate the bond order again, the bond order, this was for N2 plus, and the bond order, okay, this was for N2 minus itself. The bond order will be half into, calculate the two terms, 10 minus 5, again the bond order comes out to be 2.5, and hence you can say option number C is also the correct option for this particular question. Now we are left with just last option, option number D. It says that helium-2 plus has the same energy as compared to the two isolated helium atoms. Now dear students, this is not the case that helium-2 plus will have the same energy. So option number D is also not the correct option. So we again for this question we have got option number A as well as option number C as the correct options for this particular question. Now students, since you can see that we have already completed the second section of this complete paper, now it's a time that we should come over to section number 3. Let's see. Yes, so we have section number 3 now. I will ask you to first of all read down the instructions carefully. Once I assume that you have read the instructions, let me now come over to the paragraph questions that I do have. So this set is actually containing 2 paragraph questions. Let's try to figure out all these 2 questions that we are now left up with. Now let us first of all read paragraph 1. It says that the thermal decomposition of gaseous X2 to gaseous X at 298 Kelvin takes place according to the following equation. X2 in the gaseous state is going to form 2X in the gaseous state. The standard reaction gives energy delta G naught of the reaction. For this reaction has been given to us as positive. At the start of the reaction, there is 1 mole of X2 and no X is there. Now he is saying that as the reaction proceeds, the number of moles of X that will be formed will be given by beta. Thus, the beta equilibrium is the number of moles of X formed at equilibrium. So the reaction is carried out at a constant total pressure of 2 bar. Consider the gases to behave ideally. Now you have been given the value of R as 0.083 liters bar per Kelvin per mole, and you have been asked to do the questions. So it's question number 33 now that we have to do. So my dear students, the very first thing which many of you would have faced is like you would have thought of that this question is very lengthy, and if the question is lengthy you would have skipped this question. But again, this was the most tricky part for this year JEE Advanced. The questions that have been asked, these questions were not at all difficult. But it was like at least you should have this much patience that whatever is the question you should read it properly, try to solve each question in very step-to-step details. Now I'll show you how this question can be solved very easily. So he's saying us that the equilibrium constant Kp for this reaction at 298 Kelvin in terms of beta equilibrium is what? So you have to find out the Kp value. Now I can start it like this. It is given to me that x2 in the gaseous form is gonna give us 2x again in the gaseous form. Now if this is so, I can say that since, see, he has given us one thing. At the start of reaction, there is 1 mole of X2. So we can say when T is equal to 0, you were having it as 1 mole, and let's say this was 0. And at T is equal to T equilibrium. Now this we have to find out. And he says that as the reaction proceeds, the number of moles of X formed is given by B. So now we can say, let's say X formed is B. So I can say at equilibrium, so X formed will be B equilibrium. So how much of X2 would have reacted? 1 minus B equilibrium. So B equilibrium by 2 would have reacted. So the left out will be 1 minus B equilibrium by 2. And X formed will be B equilibrium. So what I was asked to write, Kp value, which is nothing but X in the gaseous state raised to the power 2 divided by X2 in the gaseous state. Now what can I write in this term? So actually what we have to do, rather than talking in terms of concentration, we have to say that P of X whole square divided by P of X2. This is what we have to find out. Now we know that what is partial pressure for a system. So partial pressure is nothing but total pressure multiplied by mole fraction. So let's assume the total pressure is Pt, and let's assume the mole fraction is, let's say, X for X, and for the another we can say partial pressure will be, so this is the partial pressure of X will be Pt into X of X, partial pressure of X2 will be Pt into X of X2. Now how can you calculate the mole fraction of X? Mole fraction of X can be calculated by number of moles of X, which is B equilibrium, divided by total number of moles, which is nothing 1 minus B equilibrium divided by 2 plus B equilibrium. So it comes out to be B equilibrium divided by 1 plus B equilibrium by 2. So the same way you can find out the mole fraction of X2 also. Now if I substitute all these values, whatever I have written so far, I can say that B equilibrium divided by 1 plus B equilibrium by 2 into total pressure whole square divided by 1 minus B equilibrium divided by 2 by 1 plus B equilibrium divided by 2 into P total. So this is what we have found out right now. And if I ask you to solve this orange pen stuff, you can say Kp will be equal to B equilibrium whole square Pt square by Pt. It will remain as Pt only, and then you have 1 plus B equilibrium by 2 will get cancelled. So you have 1 plus B equilibrium by 2 multiplied by 1 minus B equilibrium by 2, and if you solve it you will get 2B equilibrium square divided by 1 minus B equilibrium by 4. And hence, to solve it further, to compare it to the answers that have been given to you, you can simplify it as 8 into B equilibrium square divided by 4 minus B equilibrium square. So this is what has been found out, the value of Kp. And if I ask you to look into the options, you can find out that option number B will be the correct option for this particular question. Now students, having done with this particular question, it's the time that I should move over to question number 34th now. Now question number 34th, again, since this is a continuous question of this paragraph itself, let me ask you to read this question. The question says that the incorrect statement among the following for this reaction is. So there are 4 options that have been given to you, and you have to find out the incorrect statement. The first is, decrease in the total pressure will result in the formation of more moles of gaseous X. At the start of the reaction, dissociation of gaseous X2 takes place spontaneously. B equilibrium is 0.7 and Kc is less than 1. So now let us try to justify all these 4 options that have been given, and let's try to figure out which is correct and which is false out of them. So let me write down all the options one by one. So this is question number 34th. The first option says that decrease in the total pressure. So if you have total pressure as Pt, And if I am decreasing this total pressure, will it result in the formation of more moles of X gaseous? Now you can find out, see, pressure total. So on decreasing the pressure total, if I am decreasing it, my Q value can be written as number of moles of X2 multiplied by the total pressure divided by number of moles of X2. So this was number of moles of X whole square divided by number of moles of X2 into, again let's say N total into Q. So this will be less than Kp. Reaction will move in the forward direction, and hence we can say A option will be the correct option for this particular question. Now if I ask you to figure out option number B, for option number B, it says that at the start of reaction, the dissociation of gaseous X2 takes place spontaneously. Let's see. At the start of reaction, you can say delta G is equal to delta G naught plus RT ln Q. Now when time t is equal to 0, you can say Q will also be 0. So delta G of reaction will be nothing but a negative value, and hence you can say that the reaction will be spontaneous. And hence option number B is also the correct option. I mean, you were to figure out the incorrect option. So neither A nor B is the answer. Third says that B equilibrium is 0.7. Now let's try to figure this out also. Now if B, suppose, let us take, if B equilibrium is 0.7, I will not ask you to solve out the value of B equilibrium. Rather, since he is telling us that you can take B equilibrium as 0.7, so you find Kp value, then that will be 8 into 0.49 divided by 4 minus 0.49, and this will come out to be something 3.92 divided by 3.51. So you can find out Kp value is coming out to be greater than 1. Since it is given to you that delta G naught of reaction is greater than 0, that means it is hence proved that Kp should be less than 1. But here this option says that Kp should be greater than 1. So we have got, we have got this as the correct option, because this is the incorrect statement that we have been looking for. So let's by the time mark option number C as the answer. Let's not forget about option number D. Option number D is Kp is equal to Kc into RT raised to the power delta Ng. So we can find Kc is equal to Kp divided by R into 298 raised to the power 1 only. So you can say here also, if you solve it, you will get Kc is less than 1, and this is what has been given in option number D. So please, my dear students, do not do this stupid mistake. Many times students do like this. They find out that okay, option number A, B, D all are correct, so they'll mark it as correct. Please do refer to this thing he has asked about incorrect statement. So out of 4 only, let's say option number C was incorrect. So mark this as answer, not all these things. So many times many students have got this tendency to do a blunder in the exam by marking these kind of stuff. So don't do these stupid mistakes in your exams. Be very, very careful while you are marking the answers. So now students, I think we are left with 2 other questions, which is question number 35 and question number 36. Let me first make you read question number 35, which I suppose is another paragraph question. Yes. Let me read out the paragraph for you. The treatment of compound O with KMNO4H plus gave a compound P, which on heating with ammonia gave Q. The compound Q on treatment with bromine in the presence of NaOH produced R. On strong heating, Q gave S, which on further treatment with ethyl 1,2-bromopropanoate in the presence of KOH followed by acidification gave a compound T. The compound O is given to you. Now you have to find out. Question number 35 is what is compound number R, and another question is what is compound number T. So dear students, this question you might be feeling like this is a very pathetic question. So many things have been asked in one particular question. But again, I will ask you not to be afraid of these kind of questions. The only way how you can figure out these questions is to start solving the question by having patience and trying to write down in small steps. So let me write question 35 and question number 36 simultaneously. So starting with compound number O. The compound CO which is given to us is something like this. It has been told to us that once it is treated with H positive in the presence of KMNO4. Now you should know this thing. Whenever it is heated with H positive in the presence of KMNO4, whatever will be the alkyl groups present on the benzene ring, let they be of any length, they all will get converted into carboxylic acid. So this will be compound number P. Now further it has been said that once you add ammonia and heat the compound number P, then again this is a very simple thing. The COOH once heated with ammonia group, this will get converted into amide. So you can write CONH2 here and you can write another CONH2 here. And let's say this is compound number Q. Now to this compound number Q, if you move ahead, it has been given that to compound number Q, if you start adding bromine in the presence of NaOH. Now again you can say this is elimination of C double bond O. So you will be getting what? You will be only getting one NH2 here and another NH2 here. This is compound number R. And I think the first question was, question number 35 was the compound number R is. So this compound number R, as per you can see in the options, you will find that this is option number A. Now I can say that once I am talking about how to go from Q to R is nothing but Hofmann degradation reaction. Now after this we are asked that if this compound Q is made to be heated only. Now when two amide groups are there and you are asking them to heat away, then you can do one thing. There will be one benzene like this, and let me write it like this. You have CONH2, you have CONH2. So once you are heating it, there will be a loss of ammonia molecule, and as soon as there will be a loss of ammonia molecule, you can finally draw the structure something like this. You have CONH and you have CO. So this compound is compound number S. Now if I go further with the statement, this compound number S, as per the question, if this compound number S is treated with, first of all, let's say KOH, and then this is treated with CH3CHBr COOET. Now you should all remember that if we are going to go from S to T, this is nothing but all the steps for Gabriel phthalimide synthesis reaction. So first of all, it is going to form N minus K plus the potassium salt of phthalimide. So this was phthalic anhydride. So this is phthalimide. And then if I do N minus K positive, that is nothing but the potassium salt of phthalimide. So once I have done the potassium salt of phthalimide, and if I ask you to heat it, the compound so formed will be something like this. So you have C double bond O, N, C double bond O. So this N minus K positive, you can say that this N will attack here, let's say with this C delta plus, and this Br will go away, so that you can have CH and then you have a CH3, then you have COOET here. Now if I got this thing and if I ask you to do the hydrolysis, you will get phthalic acid, COOH, COOH, and then you will get aniline, which is NH2, CH, CH3, COOH. This is alanine. So this was the compound number T you were talking about, and if I asked you to look into the option, the compound number T was either glycine, alanine, valine or serine. So you can say option number B will be the correct option for question number 36. So students, this was all about how I help you out in solving this exam for JEE Advanced Paper 2 for 2016. Now I suppose you would have enjoyed the complete series. I suppose the questions whatever we have tried to discuss in today's lecture would have been important to you. For those who are watching this video as what they have done in the exam, so I would wish you all the very, very best for your results. And for those who are watching this video, let's say to prepare for upcoming exams, again all the best for all those students so that they can do all the well in their life. So students, now let me take a leave from you people. By the time you take care, study well and be happy.